Hi, everyone. My name is Richard Acquah, a doctoral researcher at the University of Primorska and also at Inner Renew Center of Excellence here in Slovenia. I will be sharing with you the theme titled BIM Plugin for Enhanced Service Life Modeling and Life Cycle Costing of Wood Construction. So this presentation would be about a research project we have here at the Inner Renew Center of Excellence. So in the presentation, I'm going to give an overview of this project, also talk about BIM integration with service life planning and also lifecycle costing, and finally give a demonstration of this plugin. So I'm going to start my presentation by sharing with you some trends in the wood construction industry at the moment. So at the moment, there is a lot of interest in the use of wood as a construction material. And this is largely because of wood seen as a sustainable and a more environmental friendly material. And there is a lot of support in the direction of using wood in the construction industry, especially from the European Union. There's a lot of support into research and also in industry to encourage the use of wood in construction. And this has made it possible for a lot of advances in timber processing. However, there are challenges with wood construction, and this make wood construction not so nice for some people. Some of the challenges include the fear of fire risk and also issues with moisture and also durability, pest and insect infestations, structural limitations of timber, and also limitations regard to code and regulatory in some regions, as well as some public perceptions about the performance of wood. But the good thing is that there is a lot of work being done so to address these challenges. And over the past few years, there's been a lot of research to improve the performance of wood for construction. And it started, very comprehensive work started in 2003 with a project called Wood Solutions. And since then, there's been a lot of projects purposely to estimate the service life performance of wood. And Wood LCC is one of the most recent research projects in this direction. So Wood LCC project is a project that is run by several institutions across Europe, and it has 6 work packages. Here at InnoRenew, we are working with the work package 6, and we are to develop a BIM plugin that will estimate the service life duration as well as compute for the life cycle cost of wood construction. So over the years of research into wood for advanced construction and high-rise buildings, there has been some attempts over the years to construct buildings that are high and beyond the limitations that we see wood to have. And this is because we had architects and engineers that were able to understand wood, and they were able to make use of the research that has been done over the years and implement solutions that have been invented regarding the use of wood. However, not every architect or engineer have access to these technologies. So the main purpose of the integration of our research in the Wood LCC project into a BIM tool is to make the immense research that has been done regarding service life modeling of wood available to architects and engineers working in the industry to make them make use of these research findings, to make use of these research findings and make sure that they make best use of wood in their projects. So in this project, we are integrating service life modeling, life cycle costing, and also building information modeling. So just like I'm explaining, there is a huge knowledge base on the service life performance of wood. And this is ongoing research, and it needs a lot of attention. So there is a lot of research, but most of this information is sitting down in research publications and also document in the laboratory. And the ordinary architect does not have access to this information. So in Wood LCC project, we are developing a tool that will make architects, building engineers, building users, as well as all other stakeholders in the construction industry make use of this vast knowledge. And as we all know, one tool that is common to all these people is building information modeling. So as an industry standard solution for construction professionals, our work in the Wood LCC project found it useful to integrate our findings in a way that will be useful to these professionals. So the end goal of this project is to develop a BIM tool that would be estimating service life duration of wooden elements, as well as computing for the life cycle cost of wooden elements. So in the next section of this presentation, I will talk about an overview of the plugin. So this plugin, as I have already said, is made up of two sections. The first section is to compute for the service life duration. And also the second section is to compute for the life cycle cost. And this is based on the service life duration. So we realize that most of the life cycle cost estimations are based on durations of the structure, based on some literature or some experience from professionals. But most of these estimations are not scientific based. So the purpose of the Wood LCC project is to integrate scientific findings on how the service life duration of wooden elements are, and use these values computed based on the scientific findings as input for the life cycle cost estimation. So the plugin was developed using C# and for Autodesk Revit. And it was based on ISO 15686 and also ISO 19650. And the use cases of this plugin is wood frame construction and solid wood construction, as well as wooden facades. And the plugin is basically an integration of several parts. The first is data collection and also integration of data related to the service life estimation, as well as life cycle costing into the Revit project. The second phase is to load these properties into the individual elements in the Revit project. And the third is to compute for the service life estimation. And finally, using the input, the output of the service life duration estimation as input for the life cycle costing. Yeah, so as I already mentioned, this is the user interface where we have three sections. The first section is input of parameters into the Revit project. The second section is to estimate the service life duration, and the final section is to compute for the life cycle cost. Okay, so I would want to talk about the first phase. The first phase is the data integration. So from the Wood LCC project, based on experiments done, we have a database of materials and also locations and their weather doses. So we have locations, several locations across Europe, and their weather doses based on historical weather data. We computed for the weather dose, which will be used in the computation of the service life duration. We also have different kind of materials and different treatments to those materials. And based on the material and also the treatment, we have estimated the resistance dose of the material. So these are used as inputs in the calculation of the service life estimation. So here we have the location data and also the material data. And the last part is the life cycle cost data. So we have data that are used as input in the life cycle cost estimation. The next phase of the plugin is the model creation and also input of the parameters as shared parameters into the Revit project. And the third phase is the service life estimation. So this phase is where the service life duration is computed for. So this was based on the ISO 15686 part 2, which specify how service life planning data is integrated into BIM. So in this phase, we compute the user make some selections based on the selected element in the BIM model, and a service life duration value in years is computed for. The last part of the plugin is the life cycle cost estimation part. And in this part, we are computing for the material cost, the labor cost, the maintenance cost, and also the end of life as well as the operational cost. Since we are focusing more on the material part, we leave the operation cost and also the end of life costs as user inputs. I'm going to show a demonstration of this. So this is ISO 15686 part 4, which is basically talking about how data is integrated, service life planning data is integrated into building information modeling. And the plugin was developed based on the specifications in this ISO standard. So to verify the plugin, we have 4 test structures located in 4 different locations across Europe. We have one of these structure here in Slovenia. There is another structure in Sweden, another in Germany, and also another in Austria. And in this structure, we have several sensors installed on them. And the goal is to monitor this structure over a very long time, whilst we monitor how the performance of this structure is, and whether we would need to replace or maintain certain parts of the structure, and use it as a means of validating the plugin that was developed. So I have a demonstration of the plugin here. This is the model of the test structure. So the first thing is to go into the plugin sections. And as I've already mentioned, there are 3 sections of the plugin. The first is to load the parameters related to the calculations of the service life estimation, as well as the life cycle costs, and also to set the project location, which is linked to the climatic dose of those specific locations. So we have a list of locations and climatic dose assigned to these. So the project location is set. And the next part is to load the materials. and also the treatment, as well as the resistance values to them. Then the next section, which is the life cycle calculation, we compute for the service life duration and also visualize the results. And finally, we compute for the life cycle cost. So we load in the parameters, and all those parameters needed for the calculation will be assigned to the element in the Revit model. Then the next stage is to set the project location. So I'm going to set the project location to Isola here in Slovenia, where one of the test structures are located. Yeah, so here in Isola. Then the next stage is to load the materials. So we load the materials and we have a list of all these materials. And in the background, we have the doses and also the resistance values of each of these materials and treatments to the materials. So the next stage would be to compute for the service life duration of interested parts of the element. So the main idea is to help architects and engineers to quickly compute for the service life duration and make informed decisions. So here we have the data that were loaded into the Revit model, data relating to the service life duration as well as the cost estimation. So we select an element and we go into the service life duration estimation. And in this window, we have two sections. The section on the left is to properly visualize the elements, to make decisions, selections based on the actual state of the element and also how they are connected. The wood element is connected with other structures. So we choose in ground because the selected element is in the ground. Then we set the project location. So the main concept here is to enable easy change of the project location so that we can estimate how the wooden structure is going to perform in different locations. Then you click on estimate. Then in the background, the calculations are done and the value is given. So here in this case, it's going to, for non-treated wood, when it is in the ground, is going to last for almost 4 years. And we save this service life duration as input as to the parameter, service life duration parameter that were created in the Revit project. So the next stage would be to compute for the life cycle cost. So this is the window for the life cycle cost. And just like the life cycle duration, we have also the 3D preview where we can properly visualize the individual elements in the structure. So the user would have to put input regarding escalation rate, discount rate, and also material price factor and other factors needed for the life cycle cost estimation. And when the calculate button is clicked, the life cycle cost estimation is done, and the results can also be saved as parameters within the Revit model. And there are next and previous buttons that are for moving to the next element and also computing for the life cycle duration of the elements. So this is the demonstration, and I would like to mention the benefits that we had in mind whilst we were developing this plugin was to help architects and also engineers make informed decisions with material selection. So we have a lot of materials that are commonly used here in Europe, wood materials, and several treatments that are used. And this plugin is supposed to help engineers and also architects to make proper selection of materials, and also make informed decisions to detailings, so that the wooden structure would be able to perform as expected. Yeah. So directions for future, we plan to do more testings on this plugin and also keep developing this plugin for different use cases. Currently, as I mentioned, this can be used for the wooden facade and also other wood frame construction. And we would want to in the future automate the user selections so that everything will be automated and the user will not have to click a lot of buttons, and also to improve the user experience. And in this regard, I would like to say that we are open for collaborations. So anybody who is interested in the wood construction and interested in developing this plugin can reach out for further discussions. Thank you.